In this episode, we will launch an Amazon EC2 instance. Before diving into the launch process, I recommend reviewing the official Amazon EC2 documentation and pricing. Now let's open the AWS Management Console and navigate to the VPC dashboard to get started. First, we'll create a temporary Internet gateway. Click Internet Gateways. Then click Create Internet Gateway. Enter a name for the Internet Gateway. Then click Create Internet Gateway. Next, we'll attach the temporary Internet Gateway to the VPC we created in the previous episode. Click Attach to a VPC. Choose the VPC from the previous episode. Then click Attach Internet Gateway. Next, we'll create a temporary public subnet. Click Subnets. Then click Create Subnet. Choose the VPC from the previous episode. Enter a name for the subnet. Select the UST1A availability zone. Enter the IPv4 subnet CIDR block. Then click Create Subnet. Next, select the temporary public subnet. Click Actions. Then click Edit Subnet Settings. Check the box to enable auto-assign public IPv4 address. Then click Save. Now we'll create a root table and associate it with the temporary public subnet. Click Root Tables. Then click Create Root Table. Enter a name for the root table. Choose the VPC from the previous episode. Then click Create Root Table. Click Edit Routes. Click Add Route. Select the destination. And for the target, choose the temporary internet gateway we created. Then click Save Changes. Click Subnet Associations. Then click Edit Subnet Associations. Choose the temporary public subnet. Then click Save Associations. Next, we'll create a network ACL and associate it with the temporary public subnet. Click Network ACLs. Then click Create Network ACL. Enter a name for the network ACL. Choose the VPC from the previous episode. Then click Create Network ACL. Select the network ACL we created. Click Subnet Associations. Then click Edit Subnet Associations. Choose the temporary public subnet. Then click Save Changes. Now we'll create a security group for the EC2 instance. Click Security Groups. Then click Create Security Group. Enter a name for the security group. Enter a description for the security group. Choose the VPC from the previous episode. Delete all inbound and outbound rules. Then click Create Security Group. Next, we will launch an Amazon EC2 instance. Navigate to the EC2 dashboard. Once there, click Launch Instance. Enter a name for the instance. Select Amazon Linux 2023 AMI. And choose 64-bit ARM architecture. I will select the C8G large instance type. click Create New Key Pair. Enter the key pair name. Next, choose ED25519 as the key pair type and click Create Key Pair. Select the key pair we created. In the Network Settings section, click Edit. Choose the VPC we created in the previous episode. Select the temporary public subnet. Enable auto-assign public IP. Click Select existing security group. Select the security group we created. In the Configure Storage section, click Advanced. Click Volume 1. Enter the size. Select GP3 as the volume type. Choose Encrypted. Then click Launch Instance. After launching, click on the Instances link to view your EC2 instances. Then wait for your instance to start and pass the checks. Now that the EC2 instance is running and has passed the status checks, we will connect to it using the EC2 Instance Connect option. However, before connecting, we need to allow the IP address range used by EC2 Instance Connect. Search for AWS IP address ranges. Click on this link. Below is an example of a curl command that saves the JSON file to the current directory. copy the command, open your terminal emulator, paste it, and run it. We will be using JQ to parse a local copy of the JSON file. If JQ is not installed on your system, you can install it using the appropriate installation method for your operating system. For example, on Fedora Linux, you can use the following terminal command. JQ is also available on Windows, Mac OS, and other Linux distributions. Return to your browser, click Find Address Ranges, scroll down to find a command line example using JQ that filters the JSON file for the IPv4 addresses for the specified service in the specified region. Copy the command, return to your terminal emulator, paste it. Next, modify the command to retrieve the AWS IPv4 address range for EC2 Instance Connect in the US East 1 region. And run it. Then copy the AWS IPv4 address range that appears. Return to the AWS Management Console. Navigate to Security Groups. Select the security group we created. Click Inbound Rules. Then click Edit Inbound Rules. Click Add Rule. Select SSH as the type. Paste the AWS IP address range you copied for EC2 Instance Connect as the source. Then click Save Rules. Next, navigate to Network ACLs. Select the temporary network ACL we created. Click Inbound Rules. Then click Edit Inbound Rules. Click Add New Rule. Enter 100 for the rule number. Select SSH as the type. Paste the AWS IP address range you copied for EC2 Instance Connect as the source. Then click Save Changes. click Outbound Rules, then click Edit Outbound Rules, click Add New Rule, enter 100 for the rule number, select Custom TCP as the type, paste the AWS IP address range you copied for EC2 Instance Connect as the destination. Search for custom network ACLs for your VPC. Click on this link. Scroll down. In practice, to cover the different types of clients that might initiate traffic to public-facing instances in your VPC, you can open ephemeral ports. Copy this port range. Return to Edit Outbound Rules. Paste it into the port range field. Then click Save Changes. Return to the EC2 Instances page. Select the EC2 instance we launched. Click Connect. Click Connect. After we've successfully connected to the EC2 instance, we can run this command. It displays detailed information about all the network interfaces on your Linux system, including IP addresses, subnet masks, and other related information. Here you can find the private IP address associated with the EC2 instance we launched. This command shows all TCP and UDP sockets, both listening and non-listening, in a numeric format. It also provides information about the processes that are using those sockets. We can use it to view information about SSH connections on our Linux system. To send a request to the public API service and get a response, we need to allow it through the security group and the temporary network ACL. We will create a new security group. Enter a name and description for the security group. Choose the VPC that we created in the previous episode. In the Outbound Rules section, select HTTPS as the type. Then click Create Security Group. Next, navigate to Network ACLs. Select the temporary network ACL we created. Click Inbound Rules. Then click Edit Inbound Rules. Click Add New Rule. Enter 110 for the rule number. Select Custom TCP as the type. Enter the port range. Then click Save Changes. Click Outbound Rules. Then click Edit Outbound Rules. Click Add New Rule. Enter 110 for the rule number. Select HTTPS as the type. Then click Save Changes. Return to the EC2 Instances page. Select the EC2 instance we launched. Click Actions. Click Security. Click Change Security Groups. Select the security group we just created. Click Add Security Group. Then click Save. Now return to your EC2 Instance Connect terminal window in the browser and run this command. In response, we get the public IPv4 address for our EC2 instance. To close the SSH connection, run the exit command. Once you've done that, you can close the EC2 Instance Connect terminal window in your browser. we want to deploy an ASP.NET Core Web API that will work on port 57171. So we will create a new security group to enable the EC2 instance in the EU West 2 region to communicate with this web API. Enter a name and description for the security group. Choose the VPC that we created in the previous episode. Delete all outbound rules. In the inbound rules section, click Add Rule. Select Custom TCP as the type. Enter 57171 as the port range. And specify the source. This is the public IPv4 address of the EC2 instance in the EU West 2 region. Click Create Security Group. Next, navigate to Network ACLs. Select the temporary network ACL we created. Click Outbound Rules. Then click Edit Outbound Rules. Click Add New Rule. Enter 120 for the rule number. Enter the port range. And specify the destination. Then click Save Changes. Return to the EC2 Instances page. Select the EC2 instance we launched. Click Actions, click Security, click Change Security Groups, select the security group we just created, click Add Security Group, then click Save. If you click Instance State, then Stop Instance, afterward click Instance State, then Start Instance, the public IP address will change. To prevent this change, click on Elastic IPs, then click on Allocate Elastic IP Address, and then click Allocate. Select the IP address we allocated, click Actions, then click Associate Elastic IP Address, choose the EC2 instance you launched, and click Associate. Return to the EC2 Instances page, click the Refresh Instances button, by associating an Elastic IP with your EC2 instance, you ensure that the public IP address remains consistent even if the EC2 instance is stopped and started. Next, we will connect to the EC2 instance using the SSH client option. However, before connecting, you need to allow your computer's public IP address to connect to the EC2 instance via the SSH client. Navigate to Security Groups, select this security group, click Inbound Rules, then click Edit Inbound Rules, click Add Rule, select SSH as the type, enter your computer's public IP address as the source, then click Save Rules. Next, navigate to Network ACLs, select the temporary network ACL we created, click Inbound Rules, then click Edit Inbound Rules, click Add New Rule, enter 120 for the rule number, select SSH as the type, enter your computer's public IP address as the source, then click Save Changes. Click Outbound Rules, then click Edit Outbound Rules, click Add New Rule, enter 130 for the rule number, select Custom TCP as the type, enter the port range, enter your computer's public IP address as the destination, click Save Changes. I have created a GitHub repository that contains all the code used in the AWS Exploration Series playlist on my YouTube channel. Click on this folder to view the code for the ASP.NET Core Web API project, which provides connection details for both the client and server involved in an HTTP request. Click on the Controllers folder, where you will find the Connection Details Controller class, which contains a get method. This get method returns the client IP address, client port, server IP address, server port, and all headers sent by the client. Click on the CS_proj file, where you will see that I added a NuGet package. This NuGet package integrates .NET Core applications with systemd, allowing .NET applications to be run as systemd services on Linux. This makes it easier to deploy and manage these applications in a Linux environment. Click on Program File, this line configures the application to be managed by systemd on Linux-based systems. This line adds health check services to the application. This line sets up a health check endpoint. Click on the systemd directory, where you can find the systemd service unit file used to define how this ASP.NET Core Web API is managed by systemd on a Linux-based System. Open your terminal emulator and navigate to the folder where you downloaded the source code for this ASP.NET Core Web API. We will run the .NET Publish command using the release configuration and specify the Linux ARM64 runtime because the EC2 instance type we launched is a C8G large, which uses the AWS Graviton 4 processor. AWS Graviton is a family of 64-bit ARM-based CPUs. We will publish the web API with the entire .NET runtime included, so the target machine does not need to have .NET installed. The application will be built as a single file executable. We will set the output directory to artifacts. Return to the EC2 Instances page and select the EC2 instance we launched. Click Connect. Choose the SSH client option to connect to your EC2 instance. Copy this command. Open your terminal emulator. Paste it and run it. Then return to your browser. Copy this command. And paste it into your terminal emulator. Next, modify this command to copy the single file executable and the systemd service unit file for the ASP.NET Core Web API from your local computer to the EC2 instance and run it. paste the SSH command again to connect to the EC2 instance and run it. We are now successfully connected to the EC2 instance. We will create a directory inside OPT. Move the single file executable for the ASP.NET Core Web API into it. And move the systemd service unit file to this folder. This command creates a new user group This command creates a system user that belongs to the group we just created and cannot log in. This command changes the owner of the folder and all its contents to the user and group we created. This command recursively sets the permissions of this folder and all its contents so that the owner can write, read, and execute. The group can read and execute. Others have no access except users with root privileges who can write, read, and execute. This command tells systemd to reload its configuration files. This command starts the ASP.NET Core Web API immediately and sets it to start automatically on every system boot. This command displays detailed information about the current state of the ASP.NET Core Web API service. I have already launched an EC2 instance in the EU West 2 region. Now we will open a terminal emulator and connect to that instance. Once we're connected, we'll run a command to retrieve the instance's public IP address. Next, we'll send an HTTP request from this EU West 2 instance to an ASP.NET Core Web API that I've deployed on another EC2 instance in the US East 1 region. In response, we'll see useful details such as the client's public IP and port, the server's private IP and port and all HTTP headers that were sent with the request. I don't recommend running the ASP.NET Web API on a public EC2 instance because it exposes your server to the internet, potentially making it less secure. Moreover, serving an ASP.NET Web API over HTTP is inherently insecure because sensitive data such as usernames, passwords, or API tokens can be transmitted in plain text and intercepted. Instead, using a public Amazon API gateway HTTP API with a VPC link to route traffic to an internal application load balancer and private EC2 instances ensures secure encrypted communication with no public exposure. In upcoming episodes, we will walk through launching an internal application load balancer and setting up a public Amazon API gateway HTTP API for a more secure architecture. Return to the EC2 instances page and select the EC2 instance we launched. We are going to create an Amazon machine image of this instance. This will allow us to capture the exact state of the system and easily launch new EC2 instances with the same configuration. Click Actions, click Image and Templates, click Create Image, enter a name and description for the image, click Create Image, click on AMIs and wait until the image we created is in the available state. Once the image we created is in the available state, return to the terminal emulator connected to the EC2 instance running our ASP.NET Core Web API. Run this command. This stops the service immediately and prevents it from starting automatically on system boot. Run this command. This removes the single file executable and the systemd service unit file for the ASP.NET Core Web API. After that, run this command. Now return to your browser and navigate to Security Groups. Select this security group. Click Inbound Rules. Then click Edit Inbound Rules. Remove all inbound rules. Then click Save Rules. Return to the EC2 Instances page. Next, we will launch an EC2 instance in a private subnet in the US East 1P availability zone. Click Launch Instances. Enter a name for the instance. Click Browse More AMIs. Click My AMIs. Select the image we created. I will select the C8G large instance type. In the Key Pair section, choose Proceed without key pair. Because in upcoming episodes we will connect to this EC2 instance using the Session Manager option. In the Network Settings section, click Edit. choose the VPC we created in the previous episode. Select this private subnet. Disable auto assign public IP. Click Select existing security group. Select this security group. Then click Launch Instance. Return to the EC2 Instances page. Next, we will launch an EC2 instance in a private subnet in the US East 1C availability zone. Click Launch Instances. Enter a name for the instance. Click Browse More AMIs. Click My AMIs. Select this AMI we created. I will select the CHG large instance type. In the key pair section, choose Proceed without a key pair. In the Network Settings section, click Edit. Choose the VPC we created in the previous episode. Select this private subnet. Disable auto assign public IP. Click Select existing security group. Select this security group. Then click Launch Instance. In the next episode, we'll walk through setting up an internal application load balancer to route traffic to two EC2 instances we launched in private subnets.